Okay, so inheritance and polymorphism, this is, we're talking about structuring classes now. And so we talked in class, and you'll see in the PDF that I handed out, and that's available in Moodle, that you have this idea of, a super class, which would be an all-encompassing kind of a class, like school community is the example, one of the examples I gave. And you'll see that I have a key in called School Community where you can check this out in action. But then you also have subclasses that inherit the features of the superclass. The other example that I have for you that we're going to talk a little about right now is the abstract shape class. So we're just going to talk about some of those things. Abstract classes I mentioned in class. These are going to be used when you're not actually going to instantiate this class. It's the all-encompassing thing. So I'm just going to take you over here to the abstract shape class that I wrote, and that's in your key-ins. Notice that I'm importing Turtle Graphics because I'm going to do a little bit of drawing, and I wanted a really easy way to draw without having to create an applet or anything like that. And Turtle Graphics is just really easy to use. So I thought this might be a good place to introduce that to you. Anyway, you'll notice that I have this abstract keyword that I'm using here, and I'm also using another keyword called implements. So implements means that my abstract shape class that you see here um, is going to use everything from within point. And you guys were asking about some of the different keywords that are used. If we go over to point, this is an interface, so that's another keyword we were talking a little bit about. Notice that this class is like the king of boring. It doesn't really seem to be doing anything. I just have defined here a whole bunch of methods. I don't have any constructors. I don't have any code that's actually doing anything. All I have here are a bunch of definitions of methods that could be used in any number of these shapes or abstract shapes. So again, this abstract shape is going to be my superclass. And I see that here is where I am. I have a couple of variables, and then I have a constructor here. And even though I'm never going to instantiate this an abstract shape, I'm going to need it to initialize. So later on when we talk about the test program, I'll show you what I mean by that. But I'm assuming that every abstract shape has a point like X and Y. And so the way that I set this up is I just have that as two different integers. So I constructed it a couple different ways. Then notice that I have these three methods. They're exactly the same name and parameter list as what you saw defined over here in this interface. But I still haven't defined them yet, and that's because I think I'm going to ask you to do that as part of your assignment. I do, however, have some of them defined, like get X and get Y. If you go over to the point class, I see I have a get X and get Y. I have a move, and then a toString. So if I go over to point, I see here's the move that takes in X and Y as parameters, and here's the toString. Now that all those things are going to mean different things depending. The reason I didn't write area, draw, or stretch by is because those are going to mean different things depending on the class that's going to use this superclass or this abstract superclass, abstract shape. So let's run over. Here's the class that I wrote that's going to extend or inherit all of the features of abstract shape. I'm going to call this one R triangle for right triangle. And triangles have a height and they have a base, so I'm going to declare those variables. And this keyword super is how I inherit everything, the x and the y values that were defined in abstract shape. So super just means go to the super class and inherit the features from there. So you'll notice that I do that. It's just like constructing something of abstract shape type, I guess you could say. Okay, and then now finally I define what area means. And the reason I waited is because I'm defining it just for our triangle. I might make another class and I'll call that one rectangle. Well, area is not going to be written the same way. It's not going to return 0.5 times base times height if I'm talking about a rectangle. Okay, and then draw, same thing. I'm not going to draw a rectangle the same way I would draw a right triangle or the same way I would draw a circle. So it depends on the specific shape that I'm wanting to draw. I'm going to write that method. Same with stretching it, and then notice this is polymorphism here in action, toString. So I overrode the toString method that's over here in the abstract shape class. If I have an abstract shape that I want to print out, that's going to print it out in this fashion. If I have a right triangle I want to print out, well, that's going to look quite different. It's going to print it out this way. However, notice how I'm making a call to that abstract shape class by using the super. So I am using the toString here from this abstract shape class, but when I use toString on something that's type is our triangle, this will all come out. So let's go see that in action. It's in this test program. So notice how, well, first of all, I set up a pen, called it P1. I set up a point, and this is weird. So point is my interface in this case, capital P for point. I'm calling that T1, and it's a new right triangle. So I'm saying inherit, I'm calling it, the object is a point object, but specifically this one's a right triangle. Now later on when I write other classes, I might want to set up different kinds of things, like maybe I'll write a circle class that takes in nothing. Maybe I'll write a rectangle class that takes in a length and a height or something like that, or whatever. But at any rate, I'll be able to do as many of those as I want. I can write whatever classes I want, but I can keep using all of these methods for each one of those classes. Anyway, then look at down here when I want to print this out. I'm just printing out T1, which is a point object. Specifically, it's an R triangle with these specifications. And if you look at our triangle when it gets constructed up here, that's x val, y val, the height, and the base. So it inherits everything from point, plus it gets all those specific things to a triangle. When I print it out, it prints out the triangle thing from toString in our triangle here, but it also goes over to the abstract shape and prints out the toString from here. So it's doing all kinds of stuff, and it's back and forth. So I would really recommend running through these key-ins and seeing how that all works. Maybe rewatching this video and stopping it at certain points. At any rate, good luck, and I think you guys will do just fine.